This training will cover Honeywell commercial ball valves. It will begin with a quick recap of ball valve fundamentals. Next, it will cover important specifications, the Honeywell ball valves, including features and how to select the correct one. Then it will look at ball valve applications and cover some installation tips. Lastly, it will discuss a type of ball valve called a pressure-independent control valve. Control ball valves are a unique type of rotary valve that use a ball to control flow. The ball is hollow and has two holes through the center, so that when the openings are in line with the valve ports, it will allow flow. Then the valve can be turned to restrict flow. A stem at the top of the ball protrudes through the top of the valve and allows the ball to be turned with an electric actuator. Traditionally, ball valves were two-position, open or closed. Modern control ball valves include a characterized insert that makes them perform more like a globe valve. These inserts are pressed into the ball and give the valve a characterized flow ideal for modulating control applications. As a ball valve with a characterized insert opens, the flow rate increases by a certain percentage. This is called equal percentage flow. In modulating systems, the goal is to have the heat output of the system vary directly with demand from the controller or thermostat. Most heating coils in HVAC applications have a heat transfer characteristic that is similar to this one. You can see how it transfers a large amount of energy as the valve cracks open. Then, as the valve opens further and further, the rate of energy transfer tapers off. It would be difficult to control this space accurately. A valve with an equal percentage flow characteristic only opens slightly in the first part of its travel, allowing only a small amount of hot water into the system. As you can see, when combined with the heat transfer of the coil, the net result is a linear heat delivery. This linear relationship creates optimal control and is more energy efficient and much easier to control accurately. A valve creates some resistance to flow. This can be measured by the pressure drop across the valve. Flow coefficient, or CV, is a measure of this pressure drop. It is the flow in gallons per minute through a valve at 1 psi pressure drop. With valves used for modulating or proportional control, it is critical to select the correct CV in order to have good temperature control. If the CV is too large, the valve will operate most of the time at a very small opening and can result in cavitation that could damage the valve and very poor temperature control. If the valve CV is too small, it may not provide enough flow for the application, resulting in insufficient heating or cooling. To properly size the valve, it should have about the same pressure drop as the coil it controls. To do this, calculate the CV using the GPM through and the pressure drop across the valve. The mathematical equation for CV is shown here, where Q is the rate of fluid flow in gallons per minute. The delta P is the pressure drop between the inlet and outlet port, and the P divided by P is the density or specific gravity of the media. Since these are HVAC applications, the media is probably water, with a specific gravity of 1. So this drops away from the equation. This leaves the CV equation to be the flow rate in GPM divided by the square root of the pressure drop. If the pressure drop is not known, you can use some rules of thumb. 3 to 5 psi is often assumed for small to medium-sized coils. To make the math easy, you may use 4 psi as the pressure drop and estimate the CV by taking the flow rate in GPM and dividing it by 2. If the flow rate is unknown, you can estimate it. For chilled water, multiply the coil's tons of cooling by 2.4. And for hot water applications, divide the BTU of the coil by 10,000 to get your flow rate in gallons per minute. Once you have calculated the CV, choose a valve with a CV as close to this number as possible. Unlike a globe valve, the fluid flows straight through a ball valve. Therefore, for any given size, a ball valve will have a higher CV than the globe valve. So a smaller ball valve can provide an equal CV to that of a larger globe valve. This way, a lower-cost ball valve can be used in place of a globe valve. When using ball valves that are smaller than the line size of the system, it is important to consider effective CV. This is the true CV of the valve because of the restriction caused by the reduced pipe size. These tables provide an idea of the CV reduction when the valve size is stepped down. If you look at a particular valve size, you'll notice that as the CV increases, the impact on the CV reduction becomes more significant. For example, a half-inch size valve used in a 1-inch pipe system will result in a 2.5 effective CV instead of a nominal 2.6 CV. In a similar system, an 11.7 CV valve will yield only an effective CV of 6.7. It is important to check effective CV whenever pipe reducers are used with ball valves. Be sure that an undersized valve has sufficient capacity at maximum load to heat or cool the space. The media in a system, of course, is under pressure. Because of this, it is an important consideration when selecting a valve. Here are 3 pressure parameters to consider. Close-off pressure is the maximum pressure that a valve can withstand in the fully closed position without exceeding the rated leakage. It varies from 50 to 130 psi depending on the valve size. Almost all Honeywell control ball valves have an ANSI Class 4 leakage rating. This means that in the fully closed position, the maximum leakage between the valve ports is 0.01% of the rated CV. Close-off pressure is also important because the valve must be able to close against the system pressure. With two-way valves, the valve must close off against the total dynamic pressure of the system. This is the pump discharge pressure minus the pump inlet pressure. If the total dynamic pressure of a system is not known, then use the pump pressure to be conservative. For three-way valves, the valve must be able to close off against the pressure differential across the valve. The maximum differential pressure is the maximum pressure drop between the inlet and outlet of the valve that the valve can withstand without causing damage to the valve. This is the same as the close-off pressure for Honeywell ball valves. The body or burst pressure is the pressure that the valve can withstand before developing external wall leakage. It is 240 psi for VBF and 360 psi for VBN valves. In the industry, psi and feet of head are both used to measure pressure. psi is equal to the feet of head times 0.433. Honeywell offers a broad portfolio of characterized ball valves for HVAC applications. VBN series stands for Valve Ball NPT. Threaded VBN valves are available from 1/2 inch up to 3 inches in two-way valves and up to 2.5 inches with three-way ports. They can be ordered as valve body only or as assemblies with an electric actuator. They are also used with direct couple actuators like the MN6105 or MN7105. But they all can be used with the new, easy-to-use MVN actuator on sizes up to 1 1/4 inches. VBN control ball valves are used in closed-loop, non-oxygenated systems. They can control chilled water and glycol mixture down to -22 degrees Fahrenheit and hot water up to 250 degrees at 250 psi. They are available in a wide range of sizes from 0.33 to 109 CV. The highest CV offered in a valve size is usually a full port ball. That means it does not contain a characterized insert and has a linear characteristic. This is recommended for two-position control applications. The VBN2 two-way valve is available in either nickel chrome plated brass or 316 stainless steel trim with a brass body. Trim refers to the internal components of the valve, the parts on the inside of the body of the valve. It includes the valve ball and stem. Stainless steel is selected for some applications where additional corrosion resistance is needed. The VBN3 three-way valve is manufactured with nickel chrome plated brass trim. These valves are called pressure-dependent valves because the amount of water that goes through them, the GPM, is dependent upon the pressure drop across the valve. Later, we will discuss a type of valve that delivers a certain GPM independent of the pressure drop. This is called a pressure-independent control valve. The part number of these valves begins with VR. The Honeywell VBN actuator is used exclusively with VBN valves from 1/2 up to 1 1/4 inches. It is available in floating and modulating non-spring return models. It fits in confined spaces and installs easily with no tools. Just click it into place. Not only does the VBN snap onto the valve, it also has a position indicator and a tag to identify it. VBN actuators are covered in detail in the Honeywell VBN actuator video, available on buildingcontrols.honeywell.com in the video library. The VBN is installed by simply snapping the actuator onto the valve. No tools are required. It can be mounted in any of 4 orientations, either parallel or perpendicular to the valve. To remove the VBN from the valve, simply press the light gray lever to release the actuator from the valve. The valve and actuator can be ordered as an assembly and can be tagged with information about the valve and actuator. It also includes a QR code that can be scanned on your smartphone to view the online instructions. The VBN actuator can be ordered with or without a 1-meter cable. To wire an VBN actuator without cables, simply remove the 1 screw from the conduit connection cover. Under the cover is a removable terminal block for easy wiring. The VBN also makes commissioning easy with its manual positioning control knob. The position indicator pulls out from the handle and is visible from below the actuator. The VBN actuator is compatible with both the VBN ball valve and the VRN pressure-independent ball valve. The VBN actuator is available in 2 different versions, a standard profile A series and a low profile L series. The standard profile model can meet the needs of most tight space applications, but for applications with extremely tight spaces, the low profile is available. It is important to know that the actuator is slightly different for the 2 profiles, so it is important to use the correct profile valve with the correct actuator. To match them correctly, make sure to order the actuator part with the A for the standard profile valve and the L for the low profile valve. If you order them as an assembly, we will do this for you. For applications where the actuator is exposed to outdoor elements, a rainproof actuator enclosure with see-through covers available for direct couple actuators like the MN6105 or MN7105. This enclosure is rated to NEMA 3R. This rating is equivalent to an IP14 ingress protection rating. It will protect the actuator from dirt, rain, sleet, snow, and ice. The part number is 5112-3R. Now let's take a look at the accessory offerings for the control ball valves. In addition to ordering these as part of the valve and actuator assembly, these accessories are also available individually for replacement or spares. The profile adapters and the DCA mounting kits are great items to stock for distributors because they can use these to easily switch between the VBN actuators or direct coupled actuators with the VBN or VRN valves. This can help reduce their inventory while offering a wider variety of valve and actuator combinations. Just be sure to use a matching standard or low profile actuator. The Honeywell VBN and VRN control ball valves are very easy to service. Although the valves have a 5-year warranty, over time, as with any valve, sediments in the water can cause wear on the valves. Honeywell VBN and VRN valves can be repaired by simply replacing the stem without removing the valve from the system. Stem kits are available to repair these valves. To replace the stem, close the valve, bleed any excess pressure, remove the 2 screws securing the yellow tab or the gray adapter, then slide the old stem out and insert the new one. The part number for these stem kits begin with 5112-, followed by 2 digits, depending on the size and trim of the valve. VBF stands for Valve Ball Flange. VBF valves are available as 2-way or 3-way valves in 4, 5, and 6 inches. These valves have ANSI Class 125 flange connections. They are available from 91 to 650 CV and can be used to control chilled water and hot water in closed-loop systems. All VBF 2 and 3 two-way and three-way valves are manufactured with 316 stainless steel trim and cast iron body. The three-way valves may be used in either mixing or diverting applications. VBF valves are available with or without factory-installed actuators. Actuators are available in floating and modulating types, with or without spring return, or with 24-volt two-position spring return. Honeywell VBF 5011 and VBF 5013 ball valves have the same face-to-face measurement as the V5011 and V5013 globe valves, so you can easily upgrade from an old globe valve to a modern ball valve. The VBF 5011 and VBF 5013 flanged ball valves are a lower-cost option suitable for hot and chilled water applications, but with better close-off and leakage ratings than globe valves. These valves are compatible with many Honeywell direct-coupled actuators. VBN actuators with VBN or VRN valves are configured to order. There are many actuator and valve combinations. Here's a page from the selection guide. You can see how the complete part number is made up of three things: the valve part number, the actuator part number, plus any optional accessories. Each part of the number describes more and more about the valve and actuator. In this example, the part number describes a control ball valve with NPT thread, two-way valve body. It's used with half-inch pipe. It has 1 CV and is made of plated brass with a standard profile. The MVN part number also contains details about it. MVN 613 is a floating control, fail-in-place actuator with a 1-meter whip. Here is the part of the selection guide where you can choose the correct valve and the MVN actuator for your application. It helps you to build up a valve and actuator assembly part number by picking out the valve part number based on the line size and CV, and then the floating or modulating MVN actuator and optional cable. The valve, actuator, and accessory part numbers makes for a long string of numbers. This part number might have too many characters for some of our distributor systems. To remedy this, we also have short order codes that can be used in place of the variable configuration part numbers. Each character of a short order code corresponds to a certain characteristic of the valve or valve assembly. Here is a nomenclature tree that outlines all the different options available and can be used to help decipher a valve part number. It is important to emphasize that either the variant configuration part number or the short order code can be used to order MVN actuators and VBN control ball valves, as well as the VRN pressure independent control valves. FastTrack makes ordering the correct valve much easier. It is a tool that helps you select a valve and actuator and create custom tags for them. It will price your selections and put them in a schedule. The schedule can then be sent to Honeywell for ordering. To download the FastTrack tool, visit customer.honeywell.com and click on Estimating Tools under the Support and Resources tab. You can download a version for PC or Mac, as well as a training presentation in Adobe PDF format that clearly steps you through each step to use the FastTrack tool. You may want to bookmark this site, as you should download a new FastTrack tool each time there's a price change to ensure that your version will price out correctly. Now let's take a look at some common applications for control ball valves. Here is a terminal unit that controls temperature in a segment of a building called a zone. A terminal unit provides conditioned air from the air handler to the zone. Some are air cooling only and simply regulate airflow volume with a damper. Others have a reheat coil to provide heating. Terminal units that are part of a building management system that controls the unit are called VAV, variable air volume, terminal unit, or VAV boxes. Terminal unit control valves usually require floating or proportional control, making control ball valves ideal for these applications. Another application for control ball valves is in radiant heating. A common type is baseboard heating that has been used in homes for many years. In commercial applications, it is often referred to as perimeter heating. It has hot water that flows through a pipe with fins that warms the area with radiant heat. Radiant floor is similar, but the pipes run under the floor, and the heat radiates up to the entire area. Snow melt is similar, but outdoors. It warms sidewalks and driveway areas to be clear of snow. The ball valves used in these applications generally use two-position actuators with or without spring return or failsafe. Spring return or failsafe capability with control ball valves simply means the valve is designed to return to its normal set position, either open or closed, when it loses power. For these applications when greater control is desired, modulating actuators are often used with control ball valves. Two more very common applications for control ball valves are unit ventilators and fan coils. These HVAC systems are used to condition a single room. Unit ventilators consist of dampers, a filter, a fan, and a heating and cooling coil, and the controls. They heat or cool outdoor air, return air, or a mixture to condition the space. The heating may be done with hot water and a coil, steam, or electric resistance elements. The cooling may be chilled water and a coil, or mechanical refrigeration with a DX coil. They are used for single-zone control where controlled ventilation is necessary, such as classrooms or conference rooms. Fan coils are similar to unit ventilators, but do not have an outdoor air intake. They are used in apartments, offices, hotels, and hospital rooms. Fan coils are a type of equipment called unitary equipment. Unitary devices are self-contained and usually condition one zone. The flow of hot or chilled water through the coil is often controlled with a modulating actuator and valve. Because of the size constraints of these units, a small valve and actuator like the control ball valves are ideal for these applications. Three-way ball valves configured for diverting are also commonly used to deliver either hot or chilled water to the coil for heating or cooling. The VBF flanged ball valves are generally used in large HVAC systems, such as mechanical rooms or central plants. In these applications, it is important to note again that they are designed for closed-loop systems only. Many of these applications are variable flow systems or systems using modulating control. With these, it's important to install the control ball valve so that it's downstream of the coil. It does not matter if the valve is open or closed. The coil will always flood with the system fluid or media and not starve the coil when the valve is closed. Often ball valves are two-way and control the flow through a coil, but they may also be three-way, used either to divert the flow one way or the other, or mixing where two temperature flows are mixed together to deliver a certain output temperature. Unlike globe valves, where there is one type of valve for diverting and one type for mixing, with three-way ball valves, the same valve may be used for either. Only the configuration of the piping needs to change. Here you can see the result of a misapplication of a ball valve in an open-loop system. Most control valves are designed for closed-loop systems only. The oxygen in an open-loop system can create rust on components. When rust forms around the ball of the valve, it can cause the valve to leak and bind up. Other valves, such as the VFF butterfly valve, should be used in open-loop systems. In addition to using these ball valves only on closed systems, it is important to install them properly. Here are some installation tips. Foreign objects like metal chips, solder, scale, and other debris can damage the ball seals, so it is critical to filter the media. Good installation practice begins with a system flush and water treatment. For filtration, Honeywell recommends a 50 micron or finer side stream system filter. In addition, place a 20 mesh Y strainer upstream of each valve. Remember to remove all filters and screens prior to flushing. These precautions can save a lot of expense and downtime if material prevents a valve from operating, especially if that valve is difficult to access. When using a glycol mixture to condition the water and prevent freezing, make sure the concentration of glycol to water is no more than 50%. Also be sure to use no conditioner that contains petroleum, as this can damage internal components like O-rings. Install the valve with the actuator at or above the pipe center line. Also, align the arrow of the valve body with the direction of flow. Do not install a valve at the pump discharge. The valve should be at least 8 diameters or 8 feet downstream from the pump. Prepare the threads with Teflon tape or a minimal amount of pipe dope. Then thread the pipe into the valve. Do so with 2 wrenches. Secure one wrench to the hexagonal fitting nearest the joint being tightened. Use a second wrench to screw in the threaded pipe. Do not hold the valve body with the pipe wrench. Only hold the hexagonal fitting. Also, do not twist the hexagonal fittings loose from the valve body. Doing so can cause the valve to leak. Markings on the valve body show the position of the hexagonal fittings in the original factory condition. Installation torque should not exceed 75 foot-pounds. Finally, wire the actuator and purge air from the system. The ball orientation within the valve can be determined from the notches on the top of the valve stem. When the horizontal part of the notch is parallel to the A and B ports, a 2-way valve is open. For a 3-way valve, the AB to A port is open. When the horizontal part of the notch is perpendicular to the ports, a 2-way valve is closed. For a 3-way valve, the AB to B port is open. Most of today's HVAC systems have variable flow rather than a constant flow through the coil, so the pressure of the system fluctuates with demand. This causes the flow to vary in the overall system. Each loop needs an isolation valve, a balancing valve, test ports, and of course the control valve. The purpose of the balancing valve is to balance the flow through a certain valve to the flow in the whole system. If the system is not balanced, the distribution of the flow will vary from coil to coil, resulting in poor control. Coils with too little flow will not be able to heat or cool sufficiently. Coils with surplus flow will also not heat or cool at their optimum because with the increased flow, the delta T across the coil will drop. To balance the system, the commissioner sets a balancing valve for each coil one at a time. Each time one is set, the pressure in the system changes. This changes the flow through the coils that have already been balanced. In order to balance this system, ASHRAE recommends that each valve be rebalanced at least 3 times. This is very time-consuming. A pressure-independent control valve combines the control and the balancing valves into one device, reducing installation cost and time. It completely eliminates the need to manually balance each valve during commissioning. Honeywell offers a complete line of pressure-independent control valves, with sizes ranging from 1/2 inch to 6 inches, with flow rates of 1 GPM to 469 GPM. The VRN valves cover 1/2 inch to 3 inch sizes, and the VRW goes from 2.5 to 6 inches. The flow accuracy is plus or minus 5%. They will maintain a constant flow of hot or chilled water regardless of most head pressure fluctuations. They can be ordered with Honeywell non-spring return or spring return actuators, and can be ordered separately or as assemblies with actuators. This concludes Honeywell control ball valves. For additional information, check out these sales tools at buildingcontrols.honeywell.com or customer.honeywell.com.